This video is about the integral test for series. A big part of Calculus 2 is determining whether or not a series converges. We have several tests that help us do this. Often the formula of a function can be used to define the terms of a series that are being added on. As an example, if we have f of x is equal to 2 raised to the negative x, then we could define the sum from 1 to infinity of f of n. The formula f would stay the same, so this just becomes the sum from 1 to infinity of 2 raised to the negative n. It turns out that for any f of x, there is a relationship between the integral from 1 to infinity of f of x dx and the sum from 1 to infinity of f of n. Either both expressions converge, or both expressions diverge. As an example of how to use this, let's look at the sum from 1 to infinity of 1 over square root of n. We are asked if this converges or diverges. By the theorem, we can look at the integral from 1 to infinity of 1 over square root of x instead. This integral is approachable with fundamental theorem of calculus. When we go through the process, we see that this integral diverges. This integral is approachable with fundamental theorem of calculus. When we go through the process, we see that this integral diverges. THS integral and the sum will have the same behavior, so our conclusion is that the sum from 1 to infinity of 1 over square root of n diverges, as well. Here's another example. Does the sum from 1 to infinity of 1 over n to the sixth converge or diverge? The integral test tells us that this is the same thing as asking whether the integral from 1 to infinity of 1 over x to the sixth converges or diverges. So we work out the process for determining convergence of this integral. When we do, we see that this improper integral converges to 1/5. By the integral test, this tells us that the infinite sum converges, as well.